Alright, now in this lecture we will look at top 10 interview questions that are asked during interviews at big companies like Facebook, Amazon, Apple and Microsoft. I took these questions from the book called Cracking the Coding Interview by one of my favorite authors, Gail Luckman McDowell. The programming language that is used in this book is Java, which is not the language that we are using here. But if you have a Java background, it's worth to read it. Throughout this course, I will use this book to explain real interview questions, and I will convert the code from Java to Python that make our lives easier. I have not included all BEAGLE questions from the book over here because there are some questions in the book which require data structure and algorithm knowledge that we haven't covered yet. But as we continue on these topics, I will include them. So let's continue to the first question. So the first question is, we need to find out runtime of this below code. This method takes an array as an input and calculates the sum and the product of the elements of the array separately. Then it prints them out. Now here, I want you to pause the video and think if you can come up with your own answer. Alright, hopefully you have found the answer. If not, let's do it together. We will implement the method that we used before. So we will start from the first code, which is assignment of a value to a variable. We know that it takes constant time complexity, and the second line is also the same. It takes also a constant time complexity because we are just assigning a value to a variable over here. Now we have two separate loops here. We know that looping through an array takes linear time complexity. So we have ON here. Then once again here we are assigning values to variables, which takes constant time operation. Here again we have another loop which takes linear time complexity, and then we are assigning product of I to the product, which is constant time operation. And at the end we are printing the value of sum and the value of product, which is also a constant time operation. If we combine these time complexities, we will get ON time complexity, because the fact that we iterate through array twice does not matter, because if we combine these two ON here, we can drop the constant and get ON. Question number 2. Here again, we need to find the runtime of below code. Here we have a method which takes an array as a parameter. So then inside this method, we have nested loops. Then at the end, we are printing these pairs that comes from these loops. Here again, I want you to pause the video and think if you can come up with your own answer. Alright, hopefully you have found the answer. If not, then let's do it together. Here we see that the inner loop has ON iterations. We know that any single loop runs in linear time complexity. So the time complexity for this loop, inner loop, we have ON. And the print function inside this loop takes constant time operation, which is O1. Then if you look carefully to this function, we see that the inner loop gets run m times, which means that the outer loop's time complexity will be ON squared. So if we combine all these complexities, we will get ON squared. In other words, we can see this by inspecting what the meaning of this code is. The meaning of code is, it is printing all pairs. So we have n elements in the array, and this means that the number of pairs will be n squared. So the time complexity for this function will be on n squared. And we know from our rules that if there is a function which is nested loops, and in each loop we are referring to the same array, the time complexity of this method will be n squared. In one of the previous lectures, we have discussed the rules there you can find that nested loops takes O(n) squared time complexity. Question number 3. Here again we need to find the runtime of this code. This is very similar code to the previous example, but here the inner loop starts from I plus 1. And then again we print the pairs from here. And once again I want you to pause the video and think if you can come up with your own answer. Alright, hopefully you have found the right answer. If not, then let's do it together. For this piece of code, we can find the runtime in several ways. I'll show you how to find it in 2 ways. So in the previous examples, we have found the runtimes based on memorizing common rules. We cannot always rely on these. It's important that you know the runtime and deeply understand it. So here, as the first method, I will use counting the iterations. As the inner loop starts from I plus 1, the first iteration will run n minus 1 times, where n is the length of array. And in the second iteration, the runtimes will be n minus 2. And in the third step, it will be n minus 3. And this will continue until we reach 1. Now, if we sum up these iterations, we will get the time complexity of this code. So the first run is n minus 1, then the second is n minus 2. We are summing up all of these. So we can write this equation like this, and this is the sum of the integers from 1 to n. And we know from math that sum of n integer numbers can be calculated based on this equation. So the result will be like this. So if we implement this in our equation, we will get something like this. But the original equation is with plus over here. So if we calculate this equation, we will get something like this. So here we can remove non-dominant terms and constants from here. For our case, the non-dominant term is n and the constant is 1 divided by 2. So our time complexity will be n squared, which is quadratic time complexity. Now let's look at the second way. The second way to find the time complexity for this method is called average verb. Here we know that outer loops run n times. Now the question is, how many steps does the inner loop run? For each step of outer loop, the runtimes of inner loop vary. But here we can think about average iteration. Let's imagine that for the first step, the inner loop runs 10 times. Then in the second step, it runs 9 times. Then in the third step, it runs 8 and until we reach the 1. So the average of these numbers will give us roughly 5. And this is 10 divided by 2. This means that for n numbers, our average can be n divided 2. So we know that our outer loop runs n times. Since the inner loop runs n divided by 2, we can multiply these 2 and get n squared time complexity. So with these two approaches, we can find time complexity of this method. Hopefully everything is clear for this question. Question number 4. Here we have another question that we need to find time complexity. In this case, we have two different arrays as an input, and loops of these arrays are nested. Basically, this method takes two different arrays, and in the outer loops, it runs through array A, and for each element of A, it runs array B. Now let's find what is the runtime of this code. Now here again, I want you to pause the video and think if you can come up with your own answer. Alright, hopefully you have found the right answer. If not, then let's do it together. So here, we know that if condition over here is constant time operation. So I can remove it from here and put it like this. I put constant time operation here. Now we can assume that B equals the length of array B and A is the length of array A. Now, For each element of array A, the inner loop goes b number of iterations. If A is the length of array A and B is the length of array B, then the runtime is OAB. Many students here think that this should be a quadratic time complexity. This is an extremely common mistake because here as an input we have two different arrays, and the outer and the inner loops run through completely different arrays. If they were same arrays inside these loops, then the runtime would be quadratic. Hopefully you understand the concept. Now let's continue to the next question. Question number 5. Here one more time, the method takes two different arrays as an input parameter. Then in the outer loop, it runs through array A, and for each element of array A, it runs through array B. But here, inside the inner loop, we have another loop which runs from 0 to 100,000. Now let's see what is the runtime of this code. Now here again, I want you to pause the video and think that if you can come with your own answer. Alright, hopefully you have found the right answer. If not, then let's do it together. This method is similar to the one that we discussed in question 4. We have already identified that the runtime of these two loops is OAB, where A is length of array A and the B is length of array B. And here the print function, we know that it's constant time operation. We just need to identify the loop over here, which is looping from 0 to 100,000. So here we see that this loop runs from 0 to 100,000, which is at the end a constant number. This means that nothing has really changed. So the runtime of this loop will be constant time operation. So if you combine these complexities over here, we will get runtime complexity of OAB. And that's it for this question. Let's continue to the next question. Question number 6. Okay, here this is our code. And we need to find the runtime of this code. The method that we created here is responsible for taking an array as an input and reverse the elements of the array. For example, if we have an array of numbers from 1 to 5, and if we run this function for this array, the output will be reversed. It will start from 5 to 1. What we did here, we have just changed the place of the elements of the array. So which means that last element came to the first and the others as well. So we need to find the time complexity of this method. Here again, I want you to pause the video and think if you can come up with your own answer. Alright, hopefully you have found the right answer. If not, then let's do it together. Okay, here I will go just step by step to find the time complexity of this method. In the first step, we have a loop. And we know from our rules that loop takes linear time complexity. But the here point is we are coming to the half of array, which means that the time complexity for this loop will be O(n) divided 2. And if we remove the constant from here, it will become linear time complexity, which is O(n). And in the second line, we are assigning to a variable a value, which is a constant time operation. And here again, we are doing the same by accessing the array variable. Here we are assigning a value to array's element, which is a constant time operation as well. And here we have another same operation, which is also constant time operation. These things are related to arrays. You might not know you might be interested that why assigning a value to the element of array takes constant time complexity. So in the array section of this course, we will explain this part as well. For now, you just need to know that this is constant time operation. And printing array is also constant time operation. So if you combine all these complexities, we know that we drop non-dominant terms. So here our non-dominant terms, this constant time operation, so we will get On. So that's it for this question. Let's continue to question number 7. Question number 7. Here we have a different type of question in which we need to find out equivalent of On. And we need to give a reason why we are selecting any of these as equivalent of On. Let me give you a tip here. When you have a situation in which you need to drop non-dominant terms, it's very useful to use the time complexity graph that we presented in previous lectures. This one. From here you can identify that which time complexity is dominant and which is non-dominant. Here again, one more time, I want you to pause the video and think if you can come up with your own answer. Alright, hopefully you have found the answer. If not, then let's do it together. Let's go through them one by one. So the first one says that P is less than N divided by 2, which means that N is greater than P. So if you go over here, N is dominant term and P is non-dominant term, which means that we can drop P and make this On, which is equivalent to On. So in the second one, this is a quite easy one, because here we just need to drop constant from here. The constant is 2. If we drop it, this becomes On, which is the answer that we are looking for. Now the third one. Here, our BGO complexity chart might be useful, because we need to identify which one is dominant term, On or log n. So if you look at the graph, we see that On is over here and O log n is over here, which means that On is dominant term here. So according to our rules, we can drop non-dominant term. So if we drop log n from here, this becomes On, which is the answer that we are looking for. And in the fourth one as well, we need to use graph again. From graph, we see that On log n is over here, On is over here, which means that in this case, On log n is dominant term. So we need to drop On. If we drop On, we see that our complexity will become On log n, which is not equivalent to On. And the last one. So the last one is tricky one. Many people tend to remove n from here and make it On. But this is not correct, because there is no established relationship between n and m here. So we need to keep both variables here. So this is not equivalent to On. So hopefully you have understood everything. So as I mentioned, when you want to drop non-dominant terms, this graph is very useful. So that's it. Question number 8. Here again, we need to find the time complexity of this code. This method is calculating the factorial of any given number. In case if you don't know what's factorial, it's a multiplication of numbers from 1 till n. So the factorial of n will be 1 multiplied with 2 multiplied with 3 until n. So as an example, you can see here the factorial of 3 is 1 multiplied with 2 multiplied with 3, and we get 6. So we have to take into account that the factorial of 0 is 1. And we took into account this condition in our code. So we need to identify the time complexity of this method. Now here, pause the video and think that if you can come up with your own answer. Alright, hopefully you have the right answer. If you don't figure it out, let's do it together. As you remember, we have explained this case in how to measure recursive algorithms lecture. Let me just recap it here once again quickly. So when we find the time complexity for recursive functions, we have a standard. Here we assume that if a function calls itself recursively, it takes mn time complexity. So if you look at our function over here, the function takes mn time complexity, and the if condition here will take constant time complexity. And if we think that our function takes mn time complexity, so the same function with the parameter of n minus 1 will take mn minus 1 time complexity. So based on this, we can write our equation like this. So the next step is we need to find this until we reach where n equals to 0. So we can say that when our function takes as a parameter n equals 0, the time complexity will be constant, which means that m0 will be O1. So the next step is we need to find a few more backward from n to 0. So we run our function for n minus 1, so the equation will be like this. Then we continue to the next one, which is n minus 2, and the equation will be like this. And we can continue this until we reach where the parameter is 0. Based on these conditions, we can calculate our first function, which is this one. So if I replace the equation from here to here, instead of m minus 1, I will get something like this. So if I do some calculation on this, the result will be like this. So one more time, I can replace mn minus 2 with the equation from here. So if I do some calculations on this, then I will get something like this. So if we look at this function carefully, we see that there is an iteration over here. The first value gets increased by 1, and the value over here gets decreased by 1. So we can conclude this function like this. And here a starts from 0 to n. So here all we have to do to eliminate this m function from here. So how can we eliminate it? We know that our m0 is constant time operation, which is 1. So to get m0 here, we need to replace a with n. So I'll put n instead of a here. So this will become m0. And if I calculate this, I will get n plus 1. So here we can drop constant, which is n. So the time complexity of this function will be On. So here, one more time, I try to quickly explain how to find the time complexity of a function which calls itself. Okay. Question number 9. In this question, we have two methods. In the second method, we calculate Fibonacci numbers. In the first method, we print numbers along its Fibonacci value. So what's the time complexity of this code? Now here again, I want you to pause the video and come up with your own answer. Alright, hopefully you have found the right answer. If you didn't, let's do it together. Let's start from the second method. We have learned this case in one of our previous lectures, which was called How to Measure Recursive Algorithms that Take Multiple Calls. In that lecture, we have concluded that multiple recursive algorithms take branch depth time complexity, where the branch is the number of children, that is the number of calls, and the depth is the parameter, which is n. So according to this method, our second function takes O(n) to the power of 2. Because our function calls itself twice, which we put here, and the parameter is n, so we put it here. So now here, many people will rush to conclude that since this function takes O(n) to the power of 2 time complexity, and it is get called n times here, then the time complexity of this function will be n multiplied with n to the power of 2. That's not true, because the point here is n is changing. Now here, I want to tell you that, as you see, I have chosen the questions that are relevant to the topics that we covered till now. So if you have not watched those lectures, I want you to go back and listen to them to get deep knowledge what we are doing over here. Okay, let's come back to our question. Yes, it's true that our second method takes time complexity of n to the power of 2. And here we need to calculate total complexity over here. So here the main problem is n is changing and the value of n is matters. So let's walk through each step that this method calls Fib_i function. So in the first run, when the n equals 1, our method will go 2 steps. In the second run, our method will go 2 to the power of 2 steps. In the third one, it will be 3 to the power of 2 steps. Then it will continue like this until we reach n. In the nth run, it will go n to the power of 2 steps. So this means that total amount of work is sum of powers of 2. So in one of our previous lectures, we have covered this case as well. So the sum of powers of 2 equals n plus 1 to the power of 2 minus 1. Because in our case, we don't have 0 to the power of 2, so we need to minus from here 1. So our equation will become n plus 2 to the power of 2 minus 2. So if we remove the constant from this equation, we will get time complexity of n to the power of 2. So as you see, the total work takes also n to the power of 2. Question number 9. In this question, we have 2 methods. In the second method, we calculate Fibonacci numbers. Question number 10. The following function prints the powers of 2 from 1 through n. For example, if we run this function for parameter of 4, it will print 1, 2, and 4. So we need to find the runtime of this function. So here again, I want you to pause the video and think that if you can come up with your own answer. Alright, hopefully you have found the right answer. If not, then let's do it together. Okay, to find the time complexity of this method, if you look at separately, we see that this part, this if condition here, takes constant time operation. And this part also, this is the assignment of values to the variables, also take constant time complexity. And we need to identify this part, because here the function calls itself with the half parameter. So to make it clear, let's run this function for n equals 50. So if we run our function for n equals 50, it will come over here, then calls itself with 25, which is 50 divided by 2. Then again, this function will call itself with half again. So here we will call it with the parameter of 12. Then this will continue until we reach 1. So when we reach 1, the return value from this function will be 1. So here we get 1. So from here we can go back, because we have a value here, the function, and the function does not call itself anymore. It returned the value from here. So to get the return value of this function, we will multiply it by 2, because here we are multiplying it by 2. Then we will get 2. Then it will continue to up by multiplying by 2. It will be, for this function will be 4, the other one will be 8, then here will be 16, and here we will have 32. So here we see the logic behind of this function and how it works. As you see, in this algorithm, in each step we divide our iteration into 2. So we have learned in different types of runtime complexity that if we can halve the n until we get 1, so the time complexity of this will be log n. To get more information, I want you to go to the back to the lecture in which we discussed different types of runtime complexities. There I provided very detailed information.